Let's discuss a subset of problem called prefix sum. In yesterday's video, part 1 video, I had already discussion with you regarding prefix sum and how could we find that, and what are the efficient way to find the prefix sum. So in this video, uh, we are gonna use prefix sum as a tool to find out the equilibrium point in an array. So what is equilibrium point? Equilibrium point is a number from which a left side and right side sum is equal. In front of you there is one array 1, 2, 3, 20 and 6. And if you find out that 1 plus 2 plus 3 is 6, and after 20 there is a 6 element, number 6. So that's it. That means that 20 is an equilibrium point. The left side of the 20 sum is equal to the right side of 20, that is 6. So our task today is to find out the equilibrium point in an array and return true as a return function or a call. So there are so many ideas, like we can first, like naive solution, we can find out from going from I0 to uh, j less than I, and we can find out the left sum of an array, and after that we just find out the right sum of an array, like prefix and suffix, sum of prefix and sum of suffix, and we could add that and find out if they are equal. And if not equal, we just iteratively go forward and forward. Each time we have to just subtract the prefix number from that array and add it to the suffix number, and we can easily find out that if both the sums are equal. If they equal, we should return the true. If not, we should return false. And in another way, this is a better version. We can find out that if sum from I0 to n, we could add all the numbers at a time. Then we create a some variable, and in that variable we find out left sum is equal to sum minus array of I. Means that each time we subtract the array of ith element from that sum, and we check that that difference is equal or not. If it is equal, then we can easily find the equilibrium point. So let's code it first by naive solution, and let's see how the time taken by the naive solution. So first is equilibrium point. We take an array, number of elements, and one for loop. In that for loop, I less than n, I plus plus, and we require left sum equal to 0, right sum equal to 0, and after that we have to iteratively call the function, sorry, not the function, we have to call the jth index for each time, and we have to start from j0 up to j less than I, because we have to find out the left sum. For example, if I am already in the third index, then I have to go from the 0th index to 2 index, and we have to add those elements, then exit the for loop. And after that we require another for loop to find out the right sum of that array from I plus 1 to n. That's it. So this is simple task. So again we require k is equal to I plus 1, because we are currently on ith index, so we require to iteratively go from I plus 1, and we add right sum equal to array of k. And after this, if we find out that left sum equal to right sum, then we return true. And after going through each and every ith index and checking that if the left side of sum and the right side of sum is equal, and if it is not equal, we just return back to false. Here I am taking error because I have to assign this as boolean function, then it takes true and false. So just check it out that we are doing right or wrong. Let's say then we called function is equilibrium point. You have to pass the array and n. If it is true, then it returns 1. That's it. So just check. We have to check for the dry run of this code. Already we take an array. So we'll just save it and run it. If you look at this solution, it requires two for loop for each outer loop and then inner loop. So the worst case scenario, if we consider, then it is big of n square. So we have to think little about that, how we could get it down into the big of n time complexity. Also in a space complexity, we are not taking any extra space, so it is big of one extra space. So according to space wise, it is a better solution, but time complexity wise, it is taking far beyond that because we require some efficient way. So I have required, there are 5 elements, so let's take as a 5. First element is 1. Okay, run it again. Okay, no problem. So 5 elements, first, second, third, then 20, then 6. It is not going to return, I think, because of return type of function. So let's just change that. Let's take it void only or int only, and here instead of true I return 1, and here instead of false I return 0. And let's see, check what going to be happen. So 5 elements, first is 1, 2 and 3, then 20, then 6. Let's see again running the code where we are actually messing up. So 1, 2, 3, 26. So 1. So we are getting here 1 means here equilibrium point is we are getting. Okay. So this function is doing its best. We just comment it out, and let's see the another function which can solve this problem within a big of n time complexity and without any using extra space. If we think like we can do it in big of n, but we require big of n extra space. How? Because we have to find the prefix sum, we have to find the suffix sum, we have to compare that prefix sum with the suffix sum at each point, and then we could tell about that equilibrium point is 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 occurring in that array or not. But if we do like we are finding only prefix sum within an array, within a for loop using only one for loop, and in that for loop we are just subtracting the sum variable which is containing all the arrays from the current array, then we automatically get the suffix. Without finding the suffix, we are automatically getting the suffix. How? I will tell you by doing it. So bool is equilibrium point int array in 10, then we have to take one sum variable and equate it to 0, then we have to take int array int I is equal to 0 I less than ni plus plus, and then sum is equal to array of I. In this for loop we are actually what we are doing here, we are summing up all the elements into the sum variable. After that we gonna take left sum and then equate it to 0, and for int I equal to 0 I less than n I plus plus, and if left sum equal to sum minus array of I, if this condition is true we return true, and along with this we have to change the left sum and sum minus equal to array of I. Means at each point we are actually subtracting the each element or in ith index from the sum which we are considering as our equilibrium point, and we are adding it to the left sum. Because let's see this carefully, left sum is equal to sum minus array of I. Left sum is actually the prefix and sum minus array of I is actually the suffix of that particular subarray or array. So when we doing that, we are checking the prefix equal to suffix for the ith index, and while doing so we have to subtract that ith index of array element from the left sum, and we have to add it to the left sum, because it each time we have iteratively go forward. When we go forward we have to add the left sum, because left sum is iteratively increasing, and right sum which is suffix iteratively decreasing, because at ith index we have to compare those, and that's why we have subtracting array of I from the sum. And after doing this we have to return false. So let's see also this, we are going right or not, this logic. So how many elements? 5 elements. 1 2 3 3 26. So as you see it's showing as a 1. Instead of that I'm writing here some letters so that we can easily get to know. Answer is, and do it again, 5 elements, 1, 2, 3, 26. So answer is 1. Answer is 1 means 20 is the equilibrium point. We are not finding the point where the equilibrium is occur or happen. We are just finding out the equilibrium is present in an array or not. Okay, that's it. Stay blessed, stay tuned, like, share, subscribe if you like my effort. Thank you. Stay blessed.